Greeting my learners, Mr. Matebula Law, known as Medsan. Namhlanje sizobheka nje a little bit of a chapter of physical sciences based on chemistry. Okay, let us check a rate of reaction. Now, this is a chapter esihluphayo ka grade 12, iphinde sihluphe ka grade 11. Now, ngifuna siyithathe sibheke nje ibe lula kakhulu, okay? Number 1, fanele siqale nge-definition. What is rate of reaction, okay? Now, asike siyibhale ngeformula kuqala before siyisho in words. Rate of reaction is the what? It is the change in the concentration of the products or reactants divided by change in time. So what do we say? Rate of reaction, it is the change in the concentration of the product or reactant per unit time. So that is how we define a rate of reaction, okay? It's a change in concentration of the product or reactant per unit time. Okay, now let's check. Okay, now what we need to know every time is that a rate of reaction will always be our independent variable. It's always independent. That means all the factors are depending on the what? On the rate of reaction. So what do? We say all the factors that are going to affect the rate of reaction are depending on rate of reaction. Let's continue. Now, there are factors that are affecting rate of reaction. Okay, now let's tackle them, okay? Number 1, let's deal with the first one. The first one we are going to deal with is what we call concentration. Concentration, okay? Now, concentration, we know every time that whenever I'm mixing sugar water, every time when I add sugar, the sugar water becomes more sweeter. That means I've added the what? The concentration of sugar instead of the concentration of what? Of water. Okay, now let's check. When we have a concentration as our factor, how does it affect rate? Number 1, we saw if we increase concentration, when increase concentration, the increase in concentration always increase the number of what? Of moles. When increase concentration, we increase the number of moles per unit volume. So that means whenever we are increasing the concentration, we are increasing the what? We are increasing the number of moles per unit volume. That means when we check the number of moles, whenever I add more sugar, that means it will increase the number of moles of sugar than the number of moles of what? Of water, okay? Then that means we must know that the increase in concentration increase the number of moles per unit volume. Then if it increases the number of moles per unit volume, what is happening? There will be a correct orientation. Now, what is correct orientation? It's when we are aligning the elements to particle or to collide with each other, okay? So let's say we have H2O. So if H collide with H, that's not water. But if H collide with both oxygen, we have water. So correct orientation means that they are aligning each other for correct what? Collision, okay? Now, whenever we increase correct orientation, that means we increase the rate of reaction. Okay? Whenever we increase the concentration, we increase the number of moles per unit volume. 2, we increase the what? The correct orientation. Then 3, we increase the rate of reaction. If we increase the rate of reaction, that means we have what? We have effective collision. That means we say what? We say the concentration, whenever concentration increases, the number of moles per unit volume increases. If they increases, there is correct orientation. If there's correct orientation, the rate of reaction increases. If it increases, that means what? There is effective collusion. Because every time when we are explaining factors that are affecting rate of reaction, we explain them using collusion theory. So we must explain how effective do they collide. But whenever we increase the rate of reaction, there will be what? Effective collusion. Okay. Now let's check the second factor. Okay. Now this was the first factor. Okay. The second factor we can deal with is what we call what? Is what we call catalyst. Catalyst. Okay. Now let's check catalyst. What do we do when we say we are speaking of catalyst? Catalyst is what makes the reaction to happen what? Faster. And every time when we are speaking of catalyst, they can try to trick you in a question by doing what? By showing you time, that this has reacted this time and it was completed this time. But this was completed earlier than the other one. That means that factor can be only what? Catalyst, okay? Now let's check. When I increase the catalyst, increase in catalyst have what? Increase in catalyst, it decreases the activation energy. That means whenever I increase the catalyst, I decrease the activation energy, okay? So we know from the graphs of what? Of energy, that we have an activation complex and we have activation energy. When I increase the what? The catalyst, I decrease the what? The activation energy, okay? So if I decrease the activation energy, that means it will be what? There will be a correct orientation, okay? So in a decrease in activation energy, it makes what? It makes the what? The reactants to react faster. So if they react faster, that means there will be what? Correct orientation. Therefore, if there's correct orientation, that means there will be what? There will be an increase in rate of reaction. Okay, reaction, okay? Now, if there is an increase in rate of reaction, it means what? It means that there was a what? There was an effective collusion. Okay? Now, let's repeat again. We say what? We say a catalyst, when you increase a catalyst, you decrease the what? The activation energy. If you decrease the activation energy, that means there will be correct orientation. Therefore, if there's a correct orientation, that means there will be what? An increase in rate of reaction. Okay, when we increase the catalyst, that means we decrease the activation energy. When we decrease the activation energy, there will be a what? A correct orientation. If there's a correct orientation, that means there will be increase in the rate of reaction. If there's an increase in the rate of reaction, that means there will be effective collusion. The particles are going to collide effectively. If they collide effectively, that means there was a what? A correct orientation. If there was a correct orientation, that means the rate of reaction will what? Will increase, okay? Now let's check the other factor that is affecting rate of reaction, okay? The other factor that is affecting rate of reaction, we call it what? We call it temperature. Temperature, okay? Now, how does temperature affect the rate of reaction? What do we say? We say an increase in temperature. An increase in temperature, it what? It increases the what? The kinetic energy. Okay, that means what? The more we heat water does not put itself in order, but the water, it is pushed in speed so that it collides with each other. Then it forms a what? It forms a gas, okay? We know all of the types of gases, okay? We say we have a solid, we have a liquid, and we have what? Gas. That is grade 10. But we are here, okay? So we say what? When I increase the temperature, that means I'm increasing the kinetic energy of the what? Of the particles. When I increase the kinetic energy of the particles, that means there will be what? There will be a correct orientation. Okay? There will be correct orientation. If there's a correct orientation, why if you close a pot of water and you boil them up, when you boil them up, they will change their form from liquid to gas, but they will have no air to escape, so they will change their phase again to be what? Liquid. That means there is a correct orientation, but this correct orientation changes the form to be a gas, and if it changes the form to be a gas, it changes back to be a what? A liquid. Okay, now let's continue. Then if there's correct orientation, that means there will be what? There will be an increase in rate of reaction. Okay, there will be an increase in rate of reaction. If there is increase in rate of reaction, obviously there will be what? Effective collision. Now, the question I always get from my learners, it will say, sir, what happens if we decrease the temperature? Okay, if we decrease the temperature, that means we are decreasing the what? The kinetic energy of the what? Of the particles. The particles will collide effectively. If they do not collide effectively, that means there won't be a what? A correct orientation. If there is not a correct orientation, the what? The rate of reaction will what? Will decrease. So the rate of reaction will what? Will decrease. If the rate of reaction decreases, that means there is what? Ineffective collision. Okay, so note that one, because when it comes to temperature, they play with it more often. Okay, now let's continue. So we started with 1, concentration. 2, we are on catalyst. We were in catalyst. 3, we are on what? Temperature. Okay, now let's check the other one. The other one, it is what? It is surface area. Surface area, okay? Now let's check the surface area, okay? Now, what is happening with the surface area, okay? Now, when we speak of the surface area, that means if I increase the surface area, that means I'm what? I'm increasing the what? The area of what? Of contact. Oh, okay. Let's check this one. When we increase the surface area, we are increasing the area of what? Of contact. We are increasing them we are giving them more space for them to what? To collide effectively. Okay? So when we increase the surface area, we are increasing the space for them to collide effectively. If they collide effectively, that means they will be what? Correct orientation. Okay? Orientation. If there is correct orientation, what is happening? That means there will be an increase. An increase in what? In rate of reaction, okay? Rate of reaction. There will be an increase in rate of reaction. If there is an increase in rate of reaction, that means there will be what? There will be a what? An effective collision, okay? Now, this one, it's mostly likely to use in a form of a chain or a compound, where they will draw, for example, in organic chemistry, they will draw a long chain and a branch chain. So that means if there is a long chain that is less branched, that means there was an increase in what? In a surface area. If it's more branched, that means there's a decrease in a surface area. And if there's a decrease in a surface area, that means there's a decrease in an area of contact. They do collide with each other, but not effectively. They are all colliding each other to each other in a chance that if I touch that one, if I touch it, like for example, if there is a fire in a mall, everyone rushes to the door. If everyone rushes to the door, everyone is colliding in the door. If they collide in the door, in the exit, that means what? That means each person is fighting to exit. If they are fighting to exit, it means what? It means that there was no effective collusion because everyone is seeing their way, okay? So what happened? There was a decrease in the surface area. But if there is nothing in the mall and everyone is entering and exiting, that means there's what? There's an increase in the surface area. Okay, keep that in mind, okay? Now let's continue, okay? Now let's check the other one, which is what? Pressure. The pressure only apply in gases. Please, only apply in what? In gases, okay? Gas only, guys. Let us check this one because they will not tell you that we are dealing with gases. But whenever they write a phase, they will write gaseous phase, okay, with a small letter G, okay? Let me do, for example, let's say I'm having the nitrogen gas. Then they will write a small G there. That small G means that phase of a what? A nitrogen gas. It's a what? It's a gas. Okay, so keep that in mind. Okay, then 2, when I increase in the pressure, okay, when I increase the pressure, what are you increasing the pressure? Okay, when I increase the pressure, that means I'm what? I'm decreasing the volume per unit time. How am I decreasing the volume? We know of Boyle's law on grade 11. Boyle's law says what? Says pressure is having a relationship with what? With volume. When I increase the pressure, that means I'm decreasing the what? The volume, okay? So when I increase pressure, I decrease the volume. When I increase the volume, I'm decreasing what? Pressure, okay? So in this one, we can gladly say they are inversely proportional. If they are inversely proportional, if the other increases, the other should what? Decrease. If the other decreases, the other should what? Increase, okay? So that's why we say when I increase pressure, I'm decreasing the volume per unit time. So the volume will what? Will decrease. If the volume decreases, that means there will be what? Correct orientation. Orientation, okay? There is correct orientation. If there's correct orientation, it means that there's what? There's an increase in rate of reaction. Okay? There's an increase in rate of reaction. If there's an increase in rate of reaction, that means there will be what? There will be effective collusion. Okay, that means there will be what? Effective collision. Now, let's start afresh. We have talked about the factors that are affecting rate of reaction. We said number 1 is what? It is concentration. What did we say about concentration? We said about concentration, whenever I increase concentration, I'm increasing the number of particles per unit volume, okay? Or I'm increasing the number of moles per unit volume, okay? Then 2, we entered catalyst. When I increase catalyst, that means I'm decreasing the what? I'm decreasing the activation energy, okay? Then we continue to what? We continue to surface area, okay? We said what? When I increase the surface area, I'm what? I'm increasing the area of contact. There will be increase in area of what? Contact. And then we concluded with what? Pressure. And we said it apply in only gases. When I increase the pressure, I'm decreasing the what? The volume per unit time. If it decreases the volume per unit time, that means what? There will be an effective collusion. Please make sure when you explain these factors, you use all these weights, because all these weights are there in your marking guidelines. So let us conclude with what? With factors that are affecting rate, okay? We'll meet next time when we see them in the graphs and in the calculations, okay? But for now, let us keep it here. Make sure that you subscribe to the channel, and make sure that you follow us on social medias in all platforms. Thank you.